Welcome to this explainer. Look, today we're breaking down the mandatory safety source material, covering a crucial yet highly hazardous chemical you handle every single day at the water treatment plant, 45% potassium hydroxide. We're going to look closely at the science, the specific equipment, and the absolute non-negotiable protocols required to manage this chemical safely. Okay, let's dive right in.
So today's agenda is pretty straightforward. We'll cover the mission, which is pH adjustment, then the hazards of 45% KOH, followed by our plant specifics, PPE and safe handling, and wrap up with emergencies and first aid.
Starting off with Section 1, the mission. Now, as a water treatment operator, your primary goal is to ensure the water leaving our facility is perfectly safe and stable. We use potassium hydroxide, which you'll often hear called caustic potash, to adjust the pH of the raw water. Why? Well, if the water is too acidic, it actively corrodes the community's underground piping infrastructure. By carefully injecting this KOH, we raise the pH and protect the entire city's water grid. You really aren't just handling a chemical here, you are literally preserving our public infrastructure. But I want you to notice that number, 13.5 to 14. That is the pH level of the 45% potassium hydroxide we use. To put that into perspective for a second, liquid drain cleaner sits right around a 14. This chemical is extremely basic, making it highly effective at its job of raising water pH, but incredibly destructive to human tissue. Which brings us directly to our next section.
Section 2, hazards of 45% KOH.
The safety data sheet features two very distinct warning pictograms you need to know. First, the corrosive symbol. This is a Category 1 skin and eye corrosive. It doesn't just irritate, it causes severe burns and can cause permanent eye damage, including blindness. No joke. Then the skull and crossbones. This marks it as a Category 3 oral toxin. That means it is highly toxic if swallowed, potentially causing severe burns to the mucous membranes all the way down your digestive tract.
So the crucial point here is understanding how to quickly identify these risks right out on the floor. You're going to see the NFPA hazard diamond on our tanks. Let's decode it together. The blue health square is a 3, indicating extreme danger and corrosivity. The red flammability square is a 0, meaning the chemical itself won't just catch fire. But look closely at that yellow reactivity square, a 1. That means it reacts with water to give off significant heat. Memorizing exactly what 301 means in the context of KOH is your absolute first line of defense.
Furthermore, the source material warns of a really sneaky secondary danger. It states explicitly that contact with most metals will generate flammable hydrogen gas. While KOH itself isn't flammable, if it happens to come into contact with metals like aluminum, zinc, or tin, a chemical reaction occurs that pumps out highly flammable hydrogen gas. This is exactly why it has to be stored in specially designed, corrosion-resistant containers, and why introducing stray metal tools or equipment into the tanks is strictly prohibited.
Moving on to Section 3, plant specifics. This right here is your primary storage vessel, designated tank PHB-ST-1. It's a massive, specially designed container where the bulk 45% potassium hydroxide is securely housed the moment it gets delivered to our plant. Notice the robust construction and the specific labeling? When you are out doing your rounds, this is the main hub you are inspecting for absolutely any signs of leaks or damage. From that massive primary tank, the chemical transfers over to these specific day tanks, labeled pH.DT-1. And notice that prominent 301 NFPA diamond right on the side. Every single time you approach these day tanks to check levels or perform maintenance, that diamond is staring right back at you, reminding you of the extreme health hazards inside.
Finally, the chemical moves from the day tanks to this precise location, our facility's dedicated pump rack system. These metering pumps distribute the exact calibrated amount of KOH required to adjust the raw water flowing through the plant. This is the area where you will likely spend the most time performing your maintenance or calibrations, making it a critical, everyday zone for safety awareness.
Section 4, PPE and safe handling.
Look, engineering controls are great, but your personal protective equipment, that is your last line of defense against a Category 1 corrosive. The SDS mandates that you wear impervious gloves. Totally acceptable materials include neoprene, nitrile, or PVC. You absolutely must also wear chemical splash goggles, and depending on the specific task, a full face shield to prevent any skin or eye contact from random splashes. And here is a critical exclusion to remember from the source material. Do not use polyvinyl alcohol gloves. They are completely unsuitable for this chemical. Handling the chemical itself requires very specific techniques. If you ever need to mix or dilute this stuff, there is an absolute unbreakable rule. Slowly add the KOH to cold water. Never, ever add water to the KOH. Because of that reactivity rating we talked about earlier, adding water directly to the caustic liquid generates explosive heat, which can actually cause the chemical to violently boil and splash right back onto you. Always add KOH to water. Do it slowly, and preferably use cold water to manage the temperature spike.
Section 5. Emergencies and First Aid.
I need you to commit this location to memory. Mentally map out the route from your typical workstation to this exact spot. This is the facility's emergency shower and eye wash station, situated directly adjacent to the pump rack system we looked at earlier. In an exposure event, literally every second matters. You simply do not have time to go looking for this. You need to know instinctively where it is. If you or a coworker happen to suffer skin or eye contact, here is exactly what you do. Step 1. Strip off all contaminated clothing immediately. Do not hesitate. Step 2. Flush the affected area with gently flowing water for a minimum of 20 full minutes, and don't rub the area. Step 3. A secondary operator must call for medical attention. We treat every single exposure as a serious medical emergency.
Finally, regarding environmental emergencies, if a major spill occurs, your first priority is securing the area. The SDS advises diluting the spill with water and neutralizing it with sodium carbonate, that's soda ash, if it is safe for trained personnel to do so. However, you must be aware of the federal limits. Any release of potassium hydroxide over 1,000 pounds is the EPA reportable quantity and requires immediate notification to the National Response Center.
So, let's bring it all together. Potassium hydroxide is an incredibly powerful, incredibly necessary tool, absolutely essential for protecting our entire community's underground water infrastructure. But looking at the extreme hazards and the strict protocols we've just pulled from the safety data, I want to leave you with this thought. You are protecting the city's vital lifelines, but are you diligently utilizing this training to ensure you protect your own? Take your time, inspect your gear, and respect the chemistry.